Welcome. In this lecture, which has multiple sessions, we'll explore the dual formulation of some quadratic problems. The main concepts for this is we'll have a primal formulation and it will use an expanded form of a matrix. The dual formulation will use a contracted form of the matrix. The sample problem that we can think of is one that we've encountered in a previous session, which is how can we optimize a two-spring mechanical system that has an external force that's applied to it. So we'll be looking at a quadratic objective with linear equality. We'll solve both 2D and 3D problems here. So what we mean by this quadratic problem is that the objective is a quadratic function and we have a property that's equal to 0. And specifically, what we'll look at for properties is we'll just have one property and it will be a simple linear constraint of equality. So we'll look at 3 problems in these details. Previously, we wrote the vector argument of the objective in terms of the Lagrange multiplier using this term. So it was minus the inverse of the symmetric positive definite matrix that was in the objective times the transpose of the constraint matrix times one or more Lagrange multipliers. For our simple problem, we'll have this, is the Lagrange dual will be minus 1/2 of mu squared b minus s times mu, and the derivative of this Lagrange dual with respect to the Lagrange multiplier is a simple term. And here b is our abbreviation for the constraint 1 form times the inverse of the symmetric positive definite matrix times the transpose of the constraint 1 form. And here the term S is simply the constraint